Welcome to the Bug Worksheet 5 follow along video. This video is designed to help you follow along on your 652 Bug Worksheet 5. You want to get the EWD for a 2015 Camry right-hand courtesy light ready, and we'll go ahead and start off by verifying our customer's concern of a dim right-hand courtesy light. And here we see the courtesy lights dim on the passenger side. I'm going to move over to the driver's side, and we see that the driver's side's okay.
Important to verify the concern, not only to help diagnosis, but to make sure that our repair is done correctly. I'd say we've got this one verified. It's time to check for related systems. I can either flip every switch on the car or have a look at the EWD and check for circuits that share the same power or ground. So let's have a look.
The first thing I need to do is find my wiring diagram for the courtesy light. I'll enter my vehicle information, search the word courtesy, and then I'll choose the EWD that matches the circuit that I'm looking for. And here we are. Now that I've got my circuit up on the diagram, I'll click my component, the right-hand courtesy light, and that'll center it on my screen. And I'm going to scroll over and get a full view of this complete circuit. It's pretty complex for just a simple courtesy light. But I see over here, going through this door switch, ground, which means this side of my circuit must be the ground side of the courtesy light. It goes through this diode. Current only goes one direction, but I know the gray wire is going to be ground, and I'll go on to where this green wire changes into this light blue wire. Now I suspect this is going to be power, but let's follow it through and see. And I'll trace it through these other lights that are switched. So I know I have power here, and on this side must be ground, and that confirms what I think about my courtesy light, where power and ground are. And I see it powers up a few other items, like the dome light, and the roof console. I'll probably need to go ahead and check those as well. And if I follow the wires coming out of this junction connector, I see they're fed by a relay here. If I zoom in on that, I'll see that the fuse powering this circuit looks like the 7.5 amp dome fuse. That's what's powering my courtesy lamp. Now that I've found the fuse powering this circuit, I want to know where it's at and what other circuits powering. So I'll go over to component detail. That's going to bring up a list of the circuits and the location on the vehicle. I'll click location, and we see an illustration of the junction block that houses this fuse. I'll go ahead and zoom in a little bit and highlight that fuse. And of course, down at the bottom we have buttons that show us the internal circuit as well as the physical location on the vehicle. And here we see it's in the engine room junction block. Next, I'll have a look at related circuits, and I'll see all the other circuits this fuse powers. First, I'll start with the garage door opener. We go through that cut relay and see we power something in the roof console box. Interior lights, we looked at this earlier. I see basically everything in this junction connector, and I also see my roof console box again. I don't have smart keys, so there's a lot of options I'm not going to use. I'll go into theft deterrent, and one more time we'll see that roof console box listed here as well. And the last thing I'll go into is our wireless door lock system, where again once more we'll see that roof console box listed. So it seems that I need to check that the dome light and the roof console box lights work at this point.
I'm glad I spent some time at the diagram, because I don't want to spend a bunch of time at the car checking every function on the vehicle. Plus, it's sort of in rough shape, so it's hard to tell what's related and what isn't. I think all I need to check is the dome light and the two map lights. That was the roof console box on our diagram. Those circuits seem okay. I think it's just affecting the right-hand courtesy light. But it just occurred to me, I'd better check the battery and charging system just to make sure they're not causing something strange to happen. So the battery and charging system are okay. Now I think it's time to move on to analyzing this problem.
One thing I want to think about is what type of fault I may have. I think if I had an open circuit or a short to ground, I'd probably have a circuit that didn't operate at all. If I had some kind of feedback or short to voltage, I'd have operation when I didn't intend for it to. Since I have a dim bulb, I'm going to associate that with a high resistance fault. Usually high resistance cause dim lights, slow motors, and partial operation. Let's head back over to that EWD and have one more look. Now that I have some more information about this circuit, let's have a look at the schematic. We see the ground side of the circuit here going through this diode and down through the courtesy switch. Looks like it reports something to the body control module. And then the power side of the circuit, the green wire, is fed by this junction connector, which is ultimately fed by this cut relay and a fuse. I don't really think, based off this diagram, I'll be able to eliminate the ground or the power side as the fault on this. So I think it's time for me to go ahead and trace out the color of the circuit. Well, the next thing I want to do is color code this circuit. So I'm going to start with the ground. So let's go ahead and draw this switch closed. And I'm going to draw green color going from this ground until I run into something. In this instance, that's splice. And we'll make sure this line traces green as well. Make that nice and big. And I see that it goes up to this control module, to the body control module. And then I also go through this diode. Now we will remember that electricity can pass through a diode going that direction, go in the direction it points. So power going through that diode should be just fine. I'll go ahead and continue with my ground. I am going in the right direction. Right, so we've come up to our load. We know that we have ground on this side of the load. We must have power on the other side. So let me go ahead and draw out a little bit of power here. And we'll change this color to red. And I'll follow that on up to our junction connector, where we hit a splice. And we've done a little tracing on this already. We know that our power comes through this cut relay, through IC1, IA8, and on up to our dome fuse. So now we can clearly see how this circuit is powered. It is pretty simple, and I think our diagnosis should be pretty straightforward.
I need to pick 2 or 3 tests that give me the most value. I don't need to have a look at the door courtesy switch input because the dome light and the map lights both work. I'd say the proper test here is going to be to voltage drop test the load, then voltage drop test the power and ground portions of the courtesy circuit.
At this point, I'm thinking about the test that I'm going to perform to isolate this issue. I'll probably start with a voltage drop test of the load, and I know that load should drop almost all of the source voltage. And to do that, I'll put both my meter leads back probing right at the load with the circuit switched on. If I want to voltage drop test the ground side of the circuit, I'll leave one meter lead back probing the ground side of this load, and I'll move my other lead to a known good ground. I think in this case, the front door courtesy light switch bolt, the mounting bolt, would be a great place to test because it's the actual ground this circuit uses. If I want to voltage drop test the power side, I'll move one of my meter leads back over to the positive terminal of our load, and the remaining lead I'll either go directly to the dome light fuse, or I might just move this to the positive battery terminal if that's easier. And that's going to voltage drop test everything on the portion of the circuit that we've traced in red. And of course, if I needed to narrow it down, I could move this connector to different, this test probe to different connectors. Now, one thought I have is I might just be able to do an available voltage test to test my voltage, because the ground side of this circuit is switched, not the positive side. I should always have full source voltage, going up to this load as long as my key is on and this dome light cut relay is not de-energized. So switched on, I should have full source voltage, available voltage, and I would put 1 meter lead on ground to make that measurement. Remember, this is not voltage drop, this is now available voltage, so 1 meter lead is on ground.
So I'm going to get started voltage drop testing this circuit. I want to put my meter on DC voltage, and I've got my 2 back probe leads, and I'm going to back probe this courtesy lamp. Now the circuit needs to be powered on to do voltage drop testing, and the load should drop almost all of the source voltage, which in my case is about 12.4. And right now I'm going to have to hold this in place, but you can see on my meter that I've got about 1.7 volts of voltage drop. So this bulb is not using up all of the source voltage. And again, our voltage drop is like a large, our voltage is like a large pie. And we have to share pieces of that pie. So somebody's got a large piece of my pie somewhere else. Now I need to see who it is. Now, there's a couple ways I can do this, but I want to test the positive side of the circuit, and I could voltage drop test from the battery positive terminal or the dome light fuse. But while I'm here, I could go ahead and test available voltage. And if it's something close to source voltage, then I should be in pretty good shape. So I'm going to swap one of my meter leads to a clamp and clamp to a good ground, in this case a bare piece of steel behind the dash. And I'm going to back probe the power side, the green wire going into this courtesy lamp. And it looks like I have 11.88 volts. And in this case, that's a little bit lower than I had said earlier, but we are going through the relay, we're going through that fuse, and I think my voltage may have dropped just a little bit while I was testing. It's probably time to put this on a battery charger. But for now, I'll go ahead and voltage drop test the ground side of this circuit as well. Now, I just took my clamp off. I didn't have to do that. I don't need to move that at all because it's a good ground. And all I need to do is move my back probe into the gray wire, the ground side of this courtesy lamp. And it should give me a measurement very close to 0 because this wire shouldn't drop any voltage while current passes through it. Only our load should use up voltage. So I should have a reading very close to 0, but I see on my multimeter I'm showing 10.2 volts. So the gray wire in between this courtesy lamp and ground is using up 10.2 volts. Now I'm going to have to narrow down where exactly that is. It's time to go look at that EWD one more time.
Alright, it's time to have another look at this diagram. And I know that on this gray wire in between this gray wire, my courtesy light, and ground, I've got some sort of high resistance. That could be anywhere in this section, but I need to pick a point to test. I think the next thing in line is either going to be this JI1 or I01. This splice I may not be able to get to, and this diode may be a little bit difficult to get to as well. So I'm going to hit JI1. I'll go to my component detail, find out a little bit more about it. I've got a picture of it. I know I need to be looking at terminal number 9, so I'll match that up when I'm at the vehicle. And the top link here is for location. That will show me where in the vehicle this is. I'm going to zoom in a little bit, and I see that JI1 looks like it's in that passenger kick panel, and it appears that it's going to be the very top connector.
So I had a quick look at the EWD, and I found a connector just up the line, JI1, that I want to have a look at. Now, between here and JI1, there's no other connections, so I should have almost no voltage drop. And if that's the measurement that I make, then I need to keep moving further closer to ground. Now the reason I'm testing this particular connector is because it's right here where all my equipment already is, and it's pretty easy to get to. If not, looking at this diagram, I'm probably going to be looking closer to the door courtesy switch. So let's go ahead and make that measurement. So I'm going to go from ground I'm going to move my meter lead to my courtesy lamp pin 2 and back probe at pin 2, the gray wire. And that's staying good this time. I'm going to move my other meter lead to JI1 pin 9. And again, I'm going to back probe. Now we're voltage drop testing, so the circuit has to be turned on, and I should get near 0 volts. But our multimeter shows about 9.4 volts. Again, this is a single stretch of wire that doesn't have any connectors or any breaks in between, so it shouldn't be dropping any voltage. I think we found the cause of our issue here.
Let's have one more look at the fault we found. So we were doing a voltage drop test from terminal 2 of our load, the courtesy light, over to pin 9 of JL1, connector JL1. So these are the 2 test points we were measuring at. And a good measurement for voltage drop on that section of wire would probably be something very close to 0. So something like this, 0.1 volts. But our measurement showed a much higher result, closer to 9.4 volts. Now we know this section of gray wire in between our 2 test points must have high resistance. That's using up approximately 9.5 volts.
Alright, so having a look in the area around here, it's pretty obvious where the fault is. I've got a lot of black wires going right near this connector, but of course this is a training center vehicle, so we've installed the faults. But in real life, a lot of times our failures are right near connectors, right around this door area where this flex harness is for the door, and just in general in this kick panel area, because we get so much water intrusion and a lot of our electrical runs through the area. So this is still a really common failure to see in real life. Now, all I have to do to fix this vehicle is flip a switch, but in real life we need to think about what kind of repair we want to do. We could do something like a crimp connector with heat shrink on the outside. We could solder this, or depending on what type of circuit it is, if it was SRS like this yellow connector, we'd have to replace the complete harness. But in this instance, we'll just go ahead and flip the switch and return this operation to normal. Now that I've got this one repaired, I want to do the exact same test that condemned this section of wire to prove that it's okay now. And that was to voltage drop test at pin 9, JI1. Again, back probing. And then to back probe pin 2, the gray wire at our right hand door courtesy light. And I should get something very close to 0 because that's just a plain section of wire with no connectors in between. And this time on my meter, I get very close to 0. So we can say that this vehicle has been repaired correctly. So what did we learn today? Well, we were able to tackle this problem pretty quickly because we had a solid strategic diagnostic plan. We verified what was going on, we found the conditions to make it happen, we analyzed it, we did most of our work at the desktop where it's nice and comfortable and we can think clearly. And when we actually got to the vehicle, we only had a few tests to do before we found the root cause of the problem. And just as important, once we fixed the problem, we were confident that our repair was done correctly because we saw the same test results prove that it was okay. This is the procedure we want to take on all the vehicles we diagnose. So let's get better at practicing this.